Hi everyone, I'm Kalyanee along with my teammates here today, Payam, Chaitanya and Rohit from class Csci 572 presenting our homework 3 assignment. The task for this assignment was to visualize the weapon dataset that we collected initially in the previous two assignments using Angular.js, D3.js, HTML and CSS. Today me and my teammate Chaitanya are going to be presenting this visualization to you. We have used map, dendrogram, bar chart, pie chart, line chart, and circle packing for answering the different queries that were asked in this assignment. So let's go through each of them one by one. Uh, First, we decided to first show the overall data that we collected. The data that we obtained was across the entire world for the different weapons, but most of the data that we obtained was in the United States region. The amount of data that we obtained in the rest of the world was not as much, so we decided to focus on United States for answering most of our queries. The first query related to the finding out the time-based trends that existed in the gun ads, and also for correlating temporal and spatial properties with the buyers. So for answering this query, we used a link-based algorithm which took care of facets and pivots and found out the different aspects which were important for answering this query. So this query we ran using the REST service that we created using Java. And such that the data that it returned was in the format that was compatible with D3. So in this first question, the time-based trends that were obtained have been shown using the bubble charts and the slider. As we change the slider's position, the dots increase and decrease, indicating the change in the number of gun ads in those regions. And also the red dots indicate that the transaction was unlawful, whereas the blue dot indicates that it was a lawful transaction. Moving on to the second query. The second query was about identifying similar firearm image types that were sold in the same region at the same time. For identifying these, we used a choropleth along with a histogram and a collapsible tree. So the similar firearms that were obtained, like for example, if it was rifles, then they were obtained in California, Texas, Idaho. Similarly for pistols, revolvers, musket, and handguns. So the different similar firearms were grouped by their regions, and this relation is also seen in the choropleth, because the ones having the similar firearms have the same color in the choropleth. This data is for multiple years, and we have decided to show 2007 for demo purposes. Moving on to the third query. The third query was about indicating like if the shipment of bulk arm is stolen, that if there was a rate of increase in in the sales of that particular make or model. We decided to focus on the data before and after April 2008 to answer this question. As you can see, there was around 28% of Beretta guns before April 2008, and after April 2008 it increased to 38.8. We analyzed this data and we found that this was related to the stolen goods, and the line chart that we obtained indicates that there was an increase in the Beretta guns for that particular year. The blue color corresponds to Beretta, and we can see that there was an increase. Now we move on to query 4. The query 4 was about de-identifying guns by weapon types, and also by the different year. Um, we use a stack bar chart for representing this data, and as you can see, they were de-identified by the different years. For the fifth query, the task was to identify ads and images that related to unlawful transfer, possession of explosives, WMD devices, and precursors. So we use circle packing to show this output. As you can see, for firearm possessions, there were these states which gave the data corresponding to firearm possessions, which was then we also used as you can see, WMD also had these 5 states for the possession of those weapons. And we also modeled the change in the data by showing the possession before 2011 and after 2011. Initially, it was around 48% for possession of explosives, and after 2011, it was a 50%, indicating an increase. Another feature that we used in our UI was for having the ability to search by free text. So let's say if we have a query such as firearms and we hit enter, um, as the data is being queried through Solr, we obtain a dendrogram. We represented the data that we obtained using a dendrogram, and we grouped the firearms by a content type, geolocation, and date. For the content type, these were the 10 different content types that were obtained, and each of them we've shown the IDs that they correspond, the content type corresponds to. We decided to show the top 10 geolocations for the query results that were obtained, and lastly the dates, which range from 2002 to 2015.
Hi, I'm Chaitanya. I would be talking about Banana and Facet View, which are additional two implementations for our assignment number 3. So Banana is a dashboard for analyzing the data. For the sake of recording, we have loaded the data already in this particular tab. Banana is querying Solr at runtime, so it does take some time in order to get the data loaded. We have implemented 3 different visualization. So first one is a tag cloud, second one is a map, and last one is a heat map. The default query which was used is guns, and the total number of hits obtained are 30,528. The world map clearly shows that density of United States is maximum, so the count over here is 895, which is a significant amount. The last implementation is the facet view. We have provided 3 different facets with the help of which we can analyze our data. First one is a content type, second one is the keywords, and last one is a title. Let's say I want to analyze the data using guns and classified keywords, so you just have to click on that and then the associated data will be loaded. The free text search facility can be utilized for analyzing the data belonging to a particular region, let's say Texas, and the data on the UI gets refreshed. This was our assignment implementation. I hope you all liked it. Thanks for watching.